All right, so let's get this party started. Okay, so um, and I'm going to need to put this over here. Okay, so this is the tool, Intellectus Statistics, and we'll just start banging through this. So first things first is so I'll talk about uploading data, managing data, describing or visualizing data, and analyzing data. And then I'll talk a little bit about some a priori features, and then just kind of open it up for questions and answers. So, um, so the tool is web-based. So if you're part of a university, it can be part of your single sign-on. So that can happen. Um, or you can just log into it. From as long as you have a browser, you should be good to go. So there's several ways of getting data in. One is to just start typing or pasting in a flat file. There's also example data sets that we have both by analysis or by our 65 lesson courseware that we have. Or you can upload data from different file formats. And I'm going to go ahead and do that and upload data. And I'm going to go to the Rosenberg. So once you upload data from like Qualtrics or other survey platforms, typically there's a lot of cleaning that has to be had. For example, Qualtrics often has multiple layers of headers in there. There's also often very Likert type scales that have the labels in there, strongly disagree or agree and so forth. And then there's subscales that have to be had. So all of these kinds of things have to be managed, and the data cleaning wizard helps to do that. And I'll exemplify that. So let me just get to that data set. So here you can see that I have, Q1 that has age and different age levels in there, and then sex, male and female. And then I have, K1 to K4 at pre, and I also have K1 to K4 at post. And then I also have an open-ended question, which is also very typical of a even quantitative survey, a few open-ended questions. So let's get the data cleaned up so we're ready to act on it. So first is the multiple headers. So I can delete these rows of headers here. Okay. Really, we just need the variable name or question name, and then the data. So we're just going to go ahead and select those, apply the changes, and those two rows are gone, and we'll carry on. The next is to change some of the names. Well, this was age. Okay, and this was sex. Okay. And then, okay, so that's great. So I'm going to apply those changes and then go to next. Oftentimes there's misspellings that can occur, and again, these have to be cleaned up. So there'll be, male with a capital M and male with a small m. Well, they're all indicating male. Here I have a K2 pre. I have disagree with 3 E's and with 2 E's, so I can merge those. So the AI is kind of picking that out and saying, really, these things are similar or the same, and this is what it will look like after, and I can apply those changes. I can also do that with K4. I can merge and see what it's like before and after, okay? That strongly disagree, that disagree again has 2 E's or 3 E's, and then apply changes. All right, and that takes care of misspellings. Then I do have Likert type items, and I'm going to pick, I happen to have a 5-point agreement scale. And it looks like this. Strongly disagree is a 1, to strongly agree is a 5. All of these 8 items do have that scale. So what I want to do is convert those labels into numbers, because I need to have it as numbers so I can create a composite score. You can't just average, disagree, and strongly agree. And what does that mean? So it has to be into a number. So I'm going to convert all of those and apply those changes. And that's all I have. And I'm going to go to the next. Then I'm going to add subscales. Again, very common. I have a pretest. Okay. All right. And I typically want to just, I'll say average these. And here's my pretest item. But I'll just note that, K2 is reverse coded. We can have a discussion about that if you'd like. So these are the 4 items that are going into the pretest subscale, and one of them is reverse coded. And my Likert type scale goes from 1 to 5. Apply changes. I'm going to do that again with the post test. Okay. Which is, I'm also going to average. And it's these items here, the post test scores. Okay. And my K2 is reverse coded. Apply changes. And that's all I have. So I've added 2 subscales. Okay, go to next. Typically, we recommend putting in an identifier. So if there was a 55 there, you would know, I need to go back to individual 3. Okay. So that cleans up the data pretty good. We have an ID variable, we have age, sex, and then we have the open-ended, and then we have the subscales there. So just hit finish, and we're there. So I want to do one other thing that I didn't do. So we can change the age into those levels. Okay, so I'm going to make that ordinal, and one I could just put, let's just say 29 and under. Okay, and this is 30 to 39. Okay. 40 to 49. And 50 plus. And I'm going to put it in that same variable and hit submit. So we have clean data. I'm going to do one other quick data cleaning task, which is I want to bucket these open-ended responses about their comments around leadership and type of leadership. We have a cool thing called text classification that uses AI and statistical analysis to classify or bucket these responses. And it takes just a minute. And here you can see that out of those 20 responses, or let me see here, do we have 20 full responses? Yeah. So out of the 20 responses, we've bucketed them into communication and interpersonal skills, personal community development, strategic thinking, and transformational leadership. So now I can use that bucketed or classified qualitative data to interact with these other variables if I want to. You also notice that we moved right into data management, and you can do a lot of the things I just did in data management, like edit data here. Okay, you change the names of things. Okay. I could add new rows or columns if I want to append additional data. I can reverse code here. I can impute missing data here, create subscales. And then certainly this is important, is really to download your managed data. So, right, because what did we do? We just added additional data, right? We added this pre and post, and we added a classified labels of that open-ended. Okay, so we'll want to keep that data. Okay. All right, let's move into plots. So there's 10 typical plots. They're very easy to use. And if I want to, for example, look at a profile plot, I can look at pre-test and post-test scores, for example, and I may want to group them by my different types of leadership. Okay. Hit submit. So you can kind of see that everyone had higher pre-test than they did post-test scores, and you can see what's happening for each one of these groups. Right, it looks like the communication and interpersonal skills group, really had a very rapid decline. So you could take a look at that, and then other kinds of typical plots like scatter plots, and you can look at pre-test versus post-test. Okay. Not the prettiest picture in the world, and it's not highly correlated either, but it's not the best representation of a scatter plot, but we have scatter plots. And okay, so let's go on to analyses. So the analyses really range from descriptive statistics through all the correlations and t-tests. It covers ANOVAs and MANOVAs. It does regression models, non-parametrics like chi-squares and Wilcoxon. It does structural equation modeling and path analysis, and then other types of like Preacher and Hayes, mediation and moderation, survival, and other types of analyses. What I'm going to show you has the same exact process, which is select the test, select the variables, hit calculate. That's it. So there's not a big learning curve when it comes to actually doing things. So let's go ahead and just run descriptives first. You can see the helpful scroll over. That's just kind of reinforcing for novices what this particular test is going to do. And then I'll just select the test, descriptives. I'll put in the variables of interest, and really it's just age and sex, and then pre and post, and then my bucketed responses to the open-ended. Also note helpful icons, which shares what level of measurement is allowed to go into this particular dialog box. So I'm going to look at those 5 variables and hit calculate. And here, this is an APA table for the nominal and ordinal variables. Excuse me. And you can see the frequency and percent is the appropriate way to describe that. Also, the write-up starts to drill into what's in that table. So the most frequently observed category of age was 50 plus, which was 7 individuals accounting for 35% of the sample, and so forth. For the scale variables, they also have a quick write-up, an APA table, and then again, helpful scroll overs to indicate what those terms and symbols mean. Alrighty, let's just do simple stuff. But if someone wants to see something more complicated, we can certainly do that as well. So let's just do a simple paired t-test. And we can look to compare pre versus post. I should say in almost all of these dialog boxes, there's a video tutorial to be had. Should also say that there are options along the way, okay? And most of these are set to us to evaluate some of the basic assumptions, but just know that there's other options to be had here, okay? So basically, I'm just comparing pre-test from post-test to post-test. And let's make this a little bit bigger here. So here, for each of these tests, no matter which test, the assumptions are built in. So here, for a paired t-test, it's an assumption of normality. It identifies the test, it runs the test, and then interprets the test. That's the kind of efficiency part of it. So it's banging out what's happening with respect to normality. The results are also efficiently presented. So it's doing the write-up, which is hey, guess what? There was a significant difference, okay, between pre and post. You can see that the post-test scores are lower than the pre-test. You have that interpretation sitting here. Okay. You have the APA table with scroll over, and you have the appropriate plot. You can see that the post-test scores are lower than the pre-test. You also have the when a quantitative assumption is violated, we also, as a default, enable the non-parametric equivalent test. That's just a fancy way of saying that a test that looks at the same thing, pre to post, without the assumptions. So here we can see that there was significant differences as well. Here's an interpretation of that, and then the appropriate plot for this. All righty. Before I go too much further, I want to just add a few layers of use cases here. So whether you're a faculty conducting research or you're a student doing a master's thesis or a dissertation, so we have templatized this. So this is published with Turnitin. All right. So you can use the tables directly as they are. You can use the plots directly as they are, and you can use the interpretation exactly as it is. However, you need to put this in your own voice. Okay. So that needs to go into your own voice. Ditto with these other results. So this right there is going to be published with Turnitin. Okay. So again, and you can do that just by editing it or put it into ChatGPT and say, simplify and edit, something of that sort. So that's the research use case. There's also another use case, which is very common, which is to learn. And here, what you can do is once you show students or upskilling faculty, for a paired t-test, there's an assumption, and what that assumption is, how to write up a result. That's important. They have to learn how to write somewhere, how to interpret it, how to make an appropriate table. Not that we want you making tables, but what goes in a table and what they all mean. You can present that to the student and let them get a flavor of, this is how I conduct a paired t-test. Then you can evaluate yourself to these example data sets of a paired t-test, for example. Okay. Use those use the example data sets. Okay. All right. We go back to my initial one for the moment. Use example data sets. Then when you come here, you can perhaps just share just the raw output of that t-test, okay? And then have students write that up. Okay? Students can then validate it with their interpreted output, one. They can also use the notes section to say, put it in your own words, what happened? Well, the assumption of normality was violated. However, the t-test was significant. There was a decrease in scores, and using the Wilcoxon, the medians are also declined. So that'd be something perhaps that students could put in that note section. Going further, whether you're using this for research or whether you're using it for teaching or both, you can then share those projects very simply by just clicking on the share button and putting in students or colleagues' email addresses and then hitting share. And there's a lot of notification that you'll get an email when they accept, they'll get an email, Jim wants to share, and so forth. Okay. So just know that that is there. In that shared project, there are notes at the project level. There's also the data. There's also the plots. There's also the analyses, and then the notes at the analyses. So all 5 of those components get shared. Okay. Since I was talking about um, uh, the teaching use case, it's worthwhile to share that there are 65 or so lessons that can go behind learning management systems. They're competency based, so the grades from the quizzes go to your grade book. We support you in IT to get it behind your learning management system. And if anyone would like a copy of these to review, certainly you can get a copy of these. So just to say something about the courseware. The other quick things that I want to mention are this was really kind of what we do before, once we have data. But let's just also talk about figuring out what test to use, the assumptions of that test, and the sample size needed for that test. So this is kind of a priori stuff and useful for methodologies and for IRB applications. So decision trees are just helpful to figure out, instead of walking along all these branches to get to the right test, I can use this really user-friendly, I want to predict an outcome that has a scale level of measurement while I'm doing a linear regression, and then I can jump right in to that linear regression. So the decision tree will help you figure out what test. Once I know I'm doing a t-test or a regression, I can just select the test, and then I have a downloadable and editable draft of a data plan. Here are the assumptions, here's the APA references, and so forth. Again, you should put this in your own voice, but you're not working with a blank sheet of paper. Also, we have a power analysis, so you don't have to go to G-Power or to SPSS's PASS to figure out the sample size. You just simply select the test. In this particular case, select the number of predictors, and then you have, in 2 seconds, a downloadable and editable sample size for large, medium, and small effects with a reference. So know that that's also at your fingertips. And I guess I should also, there is a consulting sessions. So just to share that with you real quick. And that's in the lower left-hand corner. And just know that students may need more hand-holding. Faculty will give, a few rounds of assistance with your project, just to kind of get you familiar, but there's really kind of low cost consulting to be had here. So I just wanted to state that part of it. Go back to my other project. Okay, so I think with that being said, let me just open up for questions and take it from there. I'm also interested in your questions, but also in your feedback, what you like, what you'd like to see. So I'm interested in learning from you as well. Do we have any questions here? Let me see. I don't see any questions at the moment.
And yeah, if you have questions later too, I'll put my contact info in here. You can always email us if you think of something after.
Yep. Well, given the contact information, I think it's worthwhile to put that up there. And let me just.
And then we'll also send this recording to everyone.
Yep. So here's some contact info. So feel free to reach out again for a trial or for a review of the courseware and so forth. All right, well, if there's not any questions, we'll just make it a short meeting. How's that?
think that's good.
Terrific. All right, well, great. Well, thank you all for joining. Look forward to hearing from you. And please do share with others the tool, and we'd appreciate that. So thank you and have a great rest of the week. Bye all.